Okay, this is for the second day on section 1.5 on graphing inequalities, graphing equations and inequalities. Okay, I'm going to go through an example on page 59, example 5. And it says to solve 2x cubed minus x squared minus 14x minus 12 is greater than or equal to 0 with an error of plus or minus 0.01. Okay, if you go in and graph that, and you're going to end up, and if you do the same thing, set the x scale to 0.01, and you're going to see a wide axis on the x-axis. And when you first look at that, it's probably just going to look like it's just touching right here. You need to do the zoom in, zoom in, zoom in, and you'll end up seeing that it does actually cross. Okay, and it is a cubic graph, so it'll look something like this. What you have to figure out is, with that plus or minus 0.01, figure out where it crosses, and I'll let you do that. Do the zoom in, zoom in. This one ends up to be a negative 1.500. Remember, we're going 3 decimal places on all our answers. Then you have to do it again, figure out where it crosses between 2 distinct tick marks, and this one ends up to be a negative 1.236. Then you have to do the same thing, figure out where it crosses over here. It's 3.236. I'll let you find those by using that zoom in technique. Now, here's how you do this. It says solve with where is this graph greater than or equal to 0. So what you're really saying, where is this graph above the y-axis? Okay, it's above the y-axis here, and it's above the y-axis here. So you figure the x values where it's above, and it's where it's equal to 0. So it would be a bracket, okay, because it includes that point, and negative 1.236, and a bracket because it includes that point. And then if you have 2 parts of the graph or 3 parts of the graph, you're going to have that union symbol. And then also, because it's an equal sign here, okay, it's going to be 3.236. And we're not looking at the y value going up, we're looking at the x value going to the right. So it would continue on to the right, so that would be parentheses. Okay, so this would be, where is that graph above greater than or equal to 0? Where is it above the y-axis? Okay? Okay? I want to go through another example on page 63. And this is example 11 on absolute values. Okay, and we're going to do this algebraically and graphically. It says solve the absolute value of 3 divided by x minus 2 is less than 1. And they want you to solve it algebraically, so that means with the paper and pencil, and support graphically. So we're going to support it on the graphing calculator. Okay, the first thing on the absolute value, remember on absolute values you'll always consider 2 cases. Let's split this up. The absolute value of 3, it's legal to split this up, and the absolute value of x minus 2 is less than, and I'm going to put this as 1 over 1. You've got, normally on an equation we would cross multiply. This is a less than symbol. We're still going to cross multiply, but whatever is on the left side on top is going to stay on top, and the absolute value of 3 is just 3. So when you cross multiply, you're going to get 3. And the arrow stays the same. We're not multiplying or dividing by a negative. So the arrow stays the same. And when you cross multiply, you're going to get the absolute value of x minus 2. Okay? Now for what we're doing, let's do, I'm going to turn this around, absolute value of x minus 2, and the arrow points to the 3, okay, absolute value of x minus 3. Let's go all the way back to your Algebra 1. You've got to split this up into two cases. X minus 2 is greater than 3. If this is a greater than symbol, it's joined with an or, and x minus 2 is less than a negative 3. Okay? You have to consider both cases when you're doing absolute value. Add 2 to both sides. X is greater than 3, or excuse me, greater than 5. X is greater than 5, or if you add 2, x is less than negative 1. Okay? And you cannot combine that back into an inequality. Okay? Now, if we graph that on a number line, okay, we would graph, I'm going to graph this both ways. X is greater than 5. It would look like this. X is less than negative 1. It would look like this. And the OR stands for the union or disjunction. It's a disjunction union, and that is your final answer. So anything greater than 5 would work into that problem, the original problem. Anything less than negative 1 would work in there. Now, if they ask you, and most of the time they're going to ask you to graph it on a coordinate plane. So on a coordinate plane, you go, and if you graph this, you're actually going to get something like this. And there's going to be an open circle here. And something like this, an open circle here. Okay. And you would say, where is that absolute value? You'd end up with the interval. Yeah, where is that absolute value less than 1? If you subtract it, it's where is it less than 0? It's from negative infinity to negative 1. Where is it below the y-axis, basically? Union that with 5 to positive infinity. Okay? So this is what it would look like in the interval, to write it as an interval. And this is what it would look like to write it as an inequality. Okay, I'm going to go back through in your Algebra 1. Let's just go back through just basically absolute values. If you do an absolute value equal to something, this equal sign is joined by or. And you consider, let's look at an example. Say I do x minus 1 is greater than 3. If I solve that, I would consider two cases. X minus 1 equals 3, or x minus 1 equals a negative 3. So x, if you add 1, x would equal 4. If you'd add 1, x would equal negative 2. And if you sub those back in, 4 minus 1 would be 3. The absolute value of that's 3. You put negative 2 in, negative 2 minus 1 is negative 3. Absolute value of that is 3. So your final answers on this one would be x equals 4 or x equals negative 2. You do need the or statement. Any equal sign is going to be an or statement. If it's the absolute value of x minus 1 is less than 3, you still consider two cases. X minus 1 is less than 3. But if it's a less than or equal to, it's an and statement. X minus 1 is greater than negative 3. Notice I reversed the arrow and the sign. So if I add 1 to both sides, x is less than 4, and add 1 to both sides, x is greater than negative 2. Okay? Now, if you were graphing this, if I graphed it on a number line, it would look like this. This is back in the Algebra 1. X is less than 4. Okay, so it'd be an open circle and an arrow to the left. X is greater than negative 2. So it'd be an open circle and an arrow to the right. And in an and statement, you can combine them. So it goes back to final answer, x is greater than negative 3 and less than 4. Okay? And the final answer graph would look like this. Okay, so anything in here would make that a true statement. Test like 0. 0 minus 1 would be negative 1. Absolute value of negative 1 is less than 3. Yeah, that works. Okay? So a less than, this determines and or. If it's less than or equal to, it's an and statement. An equal sign is an or statement. Greater than is also an or statement. The only one that's an and is less than or equal to. So if I did x minus 1 is greater than, let's say I do greater than or equal to 3. Okay, you still consider two cases in absolute value. X minus 1 is greater than or equal to 3. If this is greater than, it's an or. Greater than or equal to is also an or. X minus 1. Now, to get the other case, you got to reverse the arrow and change this sign. So add 1, you get x is greater than or equal to 4. Or add 1, you get x is less than or equal to negative 2. And or statements you cannot combine. If you were doing this on a number line, you'd say x is greater than or equal to 4. So this one would be solid. X is less than or equal to negative 2. The final graph is the union, or is a union. So that is the final graph. Okay, this is the answer algebraically. This is the answer graphically. Now, I'm not showing you the graph on the calculator. You can also graph it on the calculator. And basically what I would do on the calculator is in y sub 1, I'd put in the absolute value of x minus 1, and I would subtract the 3 over. And now you're basically saying, where is that graph greater than or equal to? So where is that graph above 0? Okay? Okay.